Today we're going to go through two topics. In our example video, we're going to go through solving circle problems on page 145, and we're going to go through prisms and cylinders on page 147. So I thought I'd group these two together because we've done them both last year. A couple of new things, but not much, and they both lead into one another. So let's get into it. We'll start off with the circle problems. We're going to go through two questions. Find the area of a circumference of a circle with radius 4 centimeters, and find the diameter of a circle if the circumference is 18.8 centimeters and the area is 38.5 centimeters. These two are different circles. Okay. So when we're doing circle problems, there's some important facts we have to know. Last year I think we listened to a song. Can't remember if we did. Last year we did all about pizzas and how to find the area and circumference of pizza so you can get the best deal or get the best crust. So the facts that you need to remember, I'm pretty sure it's in the book as well, I'll just check. Yep, it's in the green box in the book, so you can check there. But we get that the area is pi. Remember, pi was this number 3.14 something. It's on your calculator. It's how the circumference relates to the diameter. So pi times the radius squared is the area. And then for the circumference, so we can just take this 2 and move it to the front, and we get 2 pi r. Now 2 times r is the same as the diameter, so you could just remember pi d. So we have two ways of doing the circumference, either 2 pi r or pi d, and the area is pi r squared. And I quite like doing 2 pi r and pi r squared because it's the same things, just rearranged. And I always remember the area is pi r squared because when you get area, you get centimeters squared. So we always have this squared here. So we're going to need to remember these two things. I'll just leave them there for now. So the area and circumference of a circle with radius 4 centimeters. So let's do the area first. So we just plug it in. So we've got the area equals pi, this number, times the radius squared. So the radius is 4 centimeters, and we're going to square it because that's what it says to do for the formula. So we're just going to get pi times 16, and you just put this in your calculator. So I'll do it now. 16 times pi, and I got 50 point something, so I'm just going to check that. Times pi. Yep, so I usually just double check when I type them in, especially if it's something so quick as that. So I get 50.265 for blah blah blah. So I'm just going to round to one decimal place. So 50.3 centimeters squared. That's our answer. It's as easy as that. So just if you've got 2 here, you've got to be careful with the rounding because it's 6 next. We round up to 3. And like we say, the unit's centimeters squared because it's area. So now the circumference equals 2 pi r. So let's just do that one because we know what the radius is already. So 2 times pi times the radius, which is 4. So again, you can just type that in your calculator. So 2 times 4 is going to be 8, and then times pi. We get 25.13 and so on. So I'm just going to go around 25.1 centimeters. So this topic's really quite simple. It's just finding which bits you need to use and putting them in your calculator. So shouldn't be too hard. The second type of question is doing a reverse really. So we're given the circumference, or we're given the area, and we're going backwards. So again, I'm just going to write the formulas. Pi r squared, circumference equals, I'm going to write them both, 2 pi r equals pi d. So we'll do A first. The circumference is 18.8. So we're using this. We want to find the diameter, so I'm just going to use this end one because it makes it easier. Equals pi d. So now just to rearrange that, I need to get d on its own. So this is pi times d. It's not very clear, is it? Let's try again. Times d. So we do the opposite. We're going to divide by pi to get over onto this side. So we get 18.8 divided by pi equals d. We just put that in our calculator. Again, lots of calculator use in this topic. Ooh. So 18.8 divided by pi. I get 5.984. So I like to do 3 significant figures usually. So because this is because here it's 18.8, so there's 3 significant figures. I'm going to do 3 significant figures in my answer. So 5.98. It's diameter, so it's just centimeters. So again, just plugging them in. And then for area, much the same. We have pi times r squared equals 38.5. So we're going to divide by pi. We get r squared equals, let's type it in, 38.5 divided by pi. I got 12.25. And then to get rid of a squared, we have to square root it, square root both sides. So r is going to equal the square root of the answer we just got. So the square root of that, 3.500. So that's perfect. We can just leave that as 3.5 centimeters because it's the radius. And that's it for that topic, really. There, you just have to be able to go forwards and backwards. Now, for the work I want you to do, you don't have to do the brains, but if you want to stretch yourself, you should be doing them. And they're not really that hard, to be honest. It's this same thing, and then it might ask you to convert from centimeters to meters or something along those lines. So you just do the working out first, or millimeters or something. You do the working out first, and then change it at the end. So that's just one more step. But question 8 is a bit more interesting. It's combining different circle things with different shapes. It's called compound shapes. So if you want to find the area of a semicircle, you just find the area of the whole circle and then half it. Or a quarter circle, well, you find the area of a whole circle and then just quarter it. So it's pretty, it's not too bad, but you might need to think about it a little bit. But it's more interesting than just normal circles, I think. So if you want to stretch yourself, you should give that a go. They might come up as some of the harder questions in the exams, but not very often. Okay, so the next section, calculating with prisms and cylinders on page 147. Again, we did this last year. What we need to know is what a prism is. So let's just make a simple prism. And this is a prism because we have its face here, and anywhere along the whole prism it has the same face. So right at the end it's got the same face. If I cut in the middle, it's going to have the same face. So it's a prism. And we get all sorts of prisms. We get triangular prisms. That's a very bad triangular prism, trying to do it quickly. And we cut along, we'd still get this triangle all the way through. And now the new thing this year is that cylinders are also prisms. So we could have a cylinder like this, and you've got the circle here, circle at the end, and circle all the way through. So it's a prism. Sometimes you'll see cylinders like this, and it's still a prism because we just cut this way instead. And sometimes you can get some weird shaped ones. You could have a star prism. But it's incredibly hard to draw. think I did this last year, if you and you all laughed. But anyway, if it's a prism and you cut through it and you still get that star shape. So just as long as you cut through, and it's always a star shape the whole way through. So let's do an example question. It says find the volume and surface area of this shape. So you should know with prisms, you find the area of this face. So it doesn't matter what the face is, find the area of it, then times by the length. So the area of this face is just 3 along the bottom, 2 up the side. So 3 times 2 is 6. So this face here, I just rub this bit here. The face is 6 centimeters squared. So that's the area of the face. Now we just do 6 times 6, because we're doing this, times the length. So we get 36 centimeters cubed now, because centimeters squared times centimeters is centimeters cubed. So that's the volume. Easy, hopefully. And it could be a much more complicated one. We'll do another one in a moment, just to give you another example. That's the volume. And for the surface area, we just need to find the area of each of the faces and add them up. So we know this one's 6, so this one at the end is 6 as well, because like we said, it's the same all the way through. Now we just need to find all the other ones. So this rectangle here is 6 by 2. So 6 by 2. So let's do surface area. 6 by 2 is 18. So now this is 18, and this one here is also the same. So we've got 2 lots of 18. And then the only ones we haven't done are the top and the bottom. So the bottom and the top. The top is 3 by 6. So 3 by 6 is also 18. I've just realised I went wrong. Sorry. So obviously 6 times 2 is not 18, it's 12. Sorry about that. So we've got 18 on the top and we've got 12 here on the sides. Sorry about that. Now we're just going to add them all up. So we have our 12, our 18, and we have our 6 from the two ends, which was 2 times 3. And we've got 2 lots of each of these. So 2 times 12, add 2 times 18, add 2 times 6. So again, you could do that in your head, or you could do it on your calculator. So 24, add 18 times 2, add 12. So we get 72 centimeters squared. And it's centimeters squared because each one is an area. So we're just adding up the areas. So I might have made that a bit confusing with the mistake there, but you just get the area of each face and then add them up because it's the area on the surface area. So I'll do another example, clear it up a bit, and then I'll talk to you about the work you need to do. So we'll do a cylinder, seeing as though it's the new one. So let's do a quick sketch. Let's do one this way. Let's say this is 4 centimeters. Let's say the diameter is 3 centimeters. Okay, so we want the volume and surface area again. So volume is the easiest one. Volume. First we need to find the area of the face. So we know the diameter is 3. For the area we need pi times r squared. So we need pi times 1.5 squared, because if the diameter is 3, the radius is half of that, 1.5 and 1.5. So type that in your calculator. 1.5 squared is 2.25 times pi, 7.0 7 rounded centimeters squared. And then we just times that by the length. So 7.07 times 4. And we get 49. That doesn't seem right to me. I must have typed that in wrong. 7.07 times 4. Yeah, so important just to check as you go along. So we all make mistakes. We get 28.28 centimeters cubed. That's the volume. Now the surface area, we're going to have, this one's a bit more interesting. We're going to have the circle on the top and the circle on the bottom. And then I'll talk to you about the next bit. So the surface area, first we need to find the area of the circle, which we've done already here. So we have 7.07 times 2 for the top and the bottom. And we're going to add this. If we imagine a net of a cylinder, it becomes like this. So you would fold the circles up and down and wrap this around the edges, and it would make a cylinder. So when we're finding the surface area of a cylinder, we need the height here is 4. Draw it here, 4 centimeters, and the length here is the same as the circumference of the circle, because when it wraps round, it'll wrap around the circumference. So we need to find the circumference first. So we know that the diameter is 3, and the circumference equals pi times the diameter, or 2 pi r. But we're going to use this one. So circumference equals pi times 3. So if we do that on our calculator again, 3 times pi, we get 9.42 centimeters. And remember centimeters because it's just a measurement around. We haven't squared it or anything. So that's our circumference. That's this length here, this length here. So we times it by 4 to get the area of this sort of big rectangle. So we're going to do 9.42 times 4, which equals 37. Just going to check that. Times 4. 37.68 centimeters squared. And we just add these up now. So 37.68 add 7.07 times 2. And again, back to your calculator, because why not? If it's there and you can use it. And we get 51.82 centimeters squared. So sometimes you'll have to imagine this net to help you out. You have to think about which areas make up this surface area. So you've got your cylinder one there, which might be a bit more tricky, but rewatch the video. It'll help you out. You can remind yourself what to do. Again, there's also examples in the book, which will help you as well. Yeah, but the work to do, I want you to do all non-brain questions from both the pages. So that's page 146 and 148, 149. And then for the homework, so I know you're doing all the work at home, but this is sort of as homework to be handed in. I want you to do the end of unit review. You don't have to do the brains, but if you want to stretch yourself, you should be doing them. Because they just require a bit more thinking. It's good to keep pushing yourself. So have a look at them. If you think you can have a go at them. If you're not sure, you can leave them out. But you need to do the rest. And we're going to hand this in on Google Classrooms. So we're going to see how that works. I've not used it before. But the more we do it, the better we'll get. So you should have all got the code to join the class. I'll be checking that in a moment and seeing what's there. So all non-brain questions. yeah, so you can do the brains if you want to do the brains. Any questions about these topics, put in the comments, and I'll see them before the review video, which I'll be doing either tonight or tomorrow morning. So you need to be doing this work today, please, so you can get the questions in. And that's all. So good luck, and I'll talk to you soon.